All right, so 6.5 day 2, we're looking at graphing logarithmic functions. Remember, the common log is base 10 and natural log is base e. There are only logs these are the only logs your calculator can calculate. Using your calculator, graph the following on the same plane. So this is telling us to graph 10 to the x and log of x. It's just trying to get 2 exact points for each. So I'm just going to open up Desmos here real quick so you guys can take a look at what that looks like. So we have 10, we raise it to the x power, and then we have log of x. So log of x, and there we go. All right, need to zoom out here. Then I'm going to zoom in like this. All right, let's see if we can find some points here. So I am on the log of x graph. It's in black right here. Okay, so it says it's crossing right at the 0.10, so I'm going to plot that. 0.10 is right here. Let's see if we can find another one. Zoom out just a little bit. So my x is going by. There we go. If we come out here and we just kind of follow this, we hit another point at 10, 1. So we go 10, we go up 1. There's another point. Let's see which direction it's going here. So we're at like 1 there, and then 0.06, 0.04, and then it stops being able to look at it. Let's see if we zoom in. Zoom in a little bit. Let's see what it counts by now. So check that out. It says 0. It's undefined, so it never can hit 0. So that means this graph is going to go like this. So that's what our log graph will look like. Whoa, I didn't want to do that. Come like this. There we go. That's log. 10 to the x. At 0, we get 1. Right? So 0, we get 1. And then if we go up here, right at 10, we should get, or at 1, we should get 10. There it is, 110. And then we know that this stops before it gets to 0, so it's going to go up like this. If I could draw better. Sorry, everybody. So it'll look just like that. All right. So there's our 2 points based off of the log and 10 to the x function. It's asking us, what relationship do we see? Well, we've actually talked about yesterday how these two things are inverses. So if we draw in the line y equals x, look, this is a perfect reflection, right? We go here, we go 1, we go 1. We go over 9, we go down 9. Perfect reflection. This is the 0.1 comma 10. Down here on the log graph, this is the 0.10 comma 1. So we can say that this is a reflection over y is equal to x. We can say that exponentials and logarithms are inverses of each other, and we've talked about that a few times. What is the domain and range of an exponential function? Well, we know that the domain for an exponential function is always all real numbers, and then the range for this function is going from 0 to infinity. What is the domain and range of a logarithmic function? Well, if they are inverses, it should just flip, but let's double check, right? So this function, we saw that it's undefined at 0, so for the domain, it's undefined at 0, so we can't plug it in. And then it's going to the right, this arrow clearly is going to the right forever and ever, so we can say on to infinity. The range, all right, it's going down forever. This graph, although it looks like it is kind of horizontal, is going up, right? As you plug in bigger numbers, it's going to go up and up. So then this is all real numbers for the range. What do you notice? Domain and range flipped. An exponential graph has a horizontal asymptote. We've talked about that before, right? Exponentials have horizontal asymptotes. A logarithmic graph, because the line is straight up and down, has a vertical asymptote. So So, in order to help you understand how to easily graph a logarithmic function, you need to understand how to get 2 key points on the parent graph. When we graphed exponentials, the y-intercept was a key point that we found. It should make sense that when graphing logarithms, the x-intercept is going to be a key point. Let's use y equals log base 5 of x as an example. What would the x-intercept be? Remember, plug 0 in for y. So if we go right here, we're saying that 0, because that would be the x-intercept, is equal to the log base 5 of x. So then if we flip this to its exponential form, this is 5 raised to the 0 is equal to x. So then 5 raised to the 0 is just 1. Right? So what is the x-intercept? The x-intercept is 1, 0. And that is going to be true for every single log. Doesn't matter what the base is. All right? And that's because any log, if it equals 0, that's just saying whatever the base is raised to the 0 is equal to the x value. All right? And that x value is always going to be 1. So the next easy point that can be found by plugging in the same number as the base for x. Example, if you go y equals log base 5 of 5, the point would be what? So this is saying take 5, raise it to the y power, and then you get out 5, right? So y is equal to 1. So then our point is 5, 1. Now you can connect the points, making the appropriate shape. If you were going to graph the parent graph of y equals log base 2 of x, what would our x-intercept be? So our x-intercept, remember, is when y is equal to 0. So 2 raised to the 0, that's going to be 1. And this is always true. The x-intercept is always going to be 0, 1. No matter what, oh my gosh, not 0, 1. 1, 0, because the y value is 0. So 1, 0, no matter what, any log, as long as there's no transformations, has an x-intercept 1, 0. The one other easy point to plug in here is going log base 2 of 2. So make the base and the thing inside the log equal to each other, right? This is saying what does 2 need to be raised to in order to get 2, and that's just 1. So the x that we plugged in was 2, the y value that we got out was 1. So these are our 2 easy points. Okay? So let's go through some examples of how to actually do these. It says graph the following functions and state their domain and range. Remember, you need to graph the parent graph first. So log base 8, that means the parent function is y equals the log base 8 of x. In my opinion, build an XY table. Super helpful. The first value, that's the easiest thing to plug in here, is always going to be 1, right? Because 8 raised to what power gives us 1? It's always going to be 0. So you can physically always plot the point 1, 0. It's never going to be wrong. All right? The next point, the next easiest thing to plug into there is 8. Right? Because this is 8 raised to what power gives us out 8? And that is going to be 1. So we go over 8 and then up 1. Okay. Our vertical asymptote is right on this line, x equals 0. Right? This is the line x equals 0. We have our 2 points. There is no horizontal asymptote here. So the only transformation this is asking us to do is to shift all of our points down 3. Well, we have points right here, so we're going to shift them down 3. 1, 2, 3. Puts us right here. So then our final graph is going to look like this. It should look like an exponent on its side, and an exponential function on its side. Okay, let's take a look at another example. So here we have log base 5. So we have y equals the log base 5 of x. So there's always 2 great points to plug in. First one being when we have x equal to just 1. right? This is always the best one because you're saying 5 raised to what power is equal to 1, all right? If you are struggling with this, convert it, right? So that equation is 5 raised to the y is equal to x. So what's an easy number we can plug in for y here? Well, we can plug in 0. If you plug in 0, what does it give you for x? Gives you out 1, right? The next easiest point to plug into this x is the same value that is the base. So we go 5. So we're plugging in a 5 right here, right? And then you have to ask yourself, well, 5 raised to what power gives you out 5? And that's 1. So 1, 0, like always, our first point, and then 5 up 1 is our second point. Our asymptote is right here, still at x equals 0. But this time it's telling us to shift left 2, right? So that means we're going to pick up all these points and the asymptote, and we're going to shift them to the left 2. So 1, 2. And that's the only shift that happens. And then you just take this graph and you graph it through your 2 points. Okay. Continuing on, this next one is the natural log. So this is y equals natural log of x. All right. Again, if this is confusing you, what points to plug in? Switch it, right? So this is e raised to the y is equal to x. So we have our x, y points. Easiest is always to plug in 0 for this y, right? 0 for that y gives you a 1 out for x. The next easiest point is to plug into this original equation or into the changed exponential form. Into the x, you would plug e, right? So we're going to plug in an e. When we plug in an e, what's the y value that we have to use to get that? We get out 1. So we go 1, 0 as always. And then we're going to go e and then up 1. So e is 2.7. So like right here and then up 1 puts us right about there. Okay. After that, I always like to draw in the horizontal or the vertical asymptote here. Again, you don't need to draw that in right now because it's not as relevant to us. This is x equals 0 right now. But this is telling us shift left 2 and up 2. So let's just take all of those things, including the asymptote, and we're going to shift them left 2. So 1, 2 puts us here, right? So our new vertical asymptote is now x equals -2. And then it tells us to shift all of those points up 2. So we go 1, 2. So those points shifted up 2 is right there. And then we can graph through those 2 points. I'm realizing now I forgot to do domain and range for these last couple, so let's talk about them. Domain, right, for this first one, it's starting at 0, our asymptote, and then it's going to the right forever, so that's positive infinity. The range is always going to be all real numbers. All right? For this next one, summit. For this next one, the domain, this time is at -2, right? Because we're starting over here at x equals -2. So we're going from -2 to positive infinity. The range here, all real numbers. For this third one, again, the domain, we're at -2. That's our vertical asymptote, so -2 to positive infinity. Range, always all real numbers. So then let's take a look at the next one, right? This is the natural log of x equals 7. So this is y equals the natural log of x. How do we graph that? XY table. First point, always by default, 1, 0. Okay. Next point, you plug in e, because when you plug e into x, the thing that you get out is just 1. So we're at 1, 0, and then we're at e1, which would be right here. Our vertical asymptote still on the line x equals 0 right here. And then the only shift happening to these points is +7. So we're going 1, 2, 3, 4, 5, 6, 7. Puts us right here. And then we can graph that. Domain from 0 to infinity. And then the range is all real numbers. All right, last but not least, let's put all the transformations together, right? So this is y equals log base 3 of x. There's our base right there. If you need to switch it to its exponential form, by all means, still keep doing that. So 3 raised to the y is equal to x, and then build your xy table. Okay. So when you take 3 in the log, right, the first thing that we're always going to do is we're going to say, well, what if the log base 3 is of 1, right? This is always going to be 0. And then the next point you're going to plug in is 3, because when you take log of 3 to the 3, you get out 1. Okay? So then we have 1, 0. And we have 3 up 1. And then we can draw our vertical asymptote right there at x equals 0. So the first thing you need to do here is the a value. A value says take these points, multiply them by -3. So this is still 0. This one is now -3. So 0, 1 becomes -3. So we're here. Then this is telling us to shift to the right 1 and down 1. So then we're going to take all of those pinkish points and we're going to shift them to the right 1, down 1. We also will take our vertical asymptote with us to the right 1. So here we're going to the right 1. And then I'm going to take my pink points and I'm going to shift them down 1. So then our final graph is going to look like this through those 2 points. All right, and our new vertical asymptote is at x equals +1, so that tells us that the domain is from 1 to infinity, and the range is still all real numbers. All right, I know graphing logs is really confusing because I know logs are just confusing in general. If you have questions, please message me on Canvas. I would love to talk about some of this stuff with you. And as always, have a great day.